So we're going to talk about how to actually graph these equations that we've been working with. You can graph an equation by finding points on that line, and we're going to use tables to do this. So the easiest thing to do is solve for y in terms of x to get your equation ready for the table. Choose an x value, substitute the x value into the equation, and solve for y. Or with function notation, you can solve f of x equals whatever your equation is. This will always give you an ordered pair to graph, and you always want to pick a negative value, a positive value, and 0 for x to help you see what happens with the graph of the equation. So we want to see what happens on the positive side of the x-axis as well as the negative side of the x-axis, as well as when the graph crosses x equals 0. Let's look at an example. Here the equation is already given to us where y is by itself, so y has been solved in terms of x. I'm going to replace the y equals notation with function notation and create a table. Within my table, I'm going to have a column for my x values, for the values that I choose to be x, and I can pick whatever values I want. I'm just going to pick numbers that make the math easy. Then I'm going to create a table where I'm going to show my math, and then I'm going to create a column for writing the ordered pair that I find. So when x is 1, I'm just going to put 1 in the place of x in my function and solve. And I end up with f of 1 equals 5. So this gives me the ordered pair where 1 is x and 5 is y. So go ahead and solve for f of 0 and f of negative 2. Here I have solved for f of 0 and I ended up with 3, so my ordered pair was 0, 3 because I let x equal 0 and y would end up equaling 3. Then when I have x equaling 2, f of negative 2 equals negative 1. Therefore, when x is negative 2, y is negative 1. I now have 3 ordered pairs that I can plot on a graph. So I'm going to come down here to a coordinate plane. I want to make sure that I label my x and y axes, and we really should be labeling each of these axes as well. However, I don't want us to spend lots of time labeling axes. So I'll just label a couple here. Okay, so now we're going to graph our ordered pairs. So why don't you give that a shot? I have now graphed the 3 ordered pairs that are solutions, that are 3 of the solutions, 3 of the infinite solutions to this equation. So all I need to do now is connect all of these points with a line. And that's pretty easy, so I'm just going to draw a line through them. And it doesn't have to be perfect. Make sure you put arrowheads on both ends to show that there are an infinite number of solutions, which is why this line goes on forever in both directions. Go ahead and solve this equation for y in terms of x. Write it with function notation within your table. And then find all 3 ordered pairs based on the x values that I've given you. And then graph the 3 ordered pairs on your coordinate plane and connect them. This is a linear equation, and the way I can tell is that the x doesn't have an exponent, which means it has an understood exponent of 1, and the y doesn't have an exponent, which means it has an understood exponent of 1, and neither one's in a square root. So as long as that's the case, as long as I just have an x and a y, or an x or a y, and they have an understood exponent of 1, I'll have a linear equation. So go ahead and give this example a shot. Go ahead and check your answers. I ended up with the ordered pairs 2, 7, 0, 3, negative 1, 1. Notice I'm showing less work, and it's okay if you show less work as well. Try this example. It's a little tricky. I'm going to give you a couple of hints. First of all, don't write this in function notation. Just leave it the way you see it. So let's write y equals 2 for our equation. Now when y equals 2, what that means is that y is always 2 no matter what x is. So see if you can figure out what this equation is going to look like when you graph it. When y equals 2, that means that there's basically a 0 in front of your x. So this is y equals 0x plus 2. So the coefficient of x is 0. What that means is x can be anything and y will always be 2. So I chose 3 as one of my examples for x and y equaled 2. I chose 0 and y equaled 2. And then I chose -1 and that equaled 2 as well. So y is always going to be 2 in the equation y equals 2, and x can be anything. And you end up with what looks like a horizontal line. It is a horizontal line. And any equation where y equals a number, a constant, will always give you the equation that will look like a horizontal line. So if I said y equaled -5, that means y is always -5. 1, 2, 3, 4, 5. No matter what x is. So x can be anything. Y will always be -5. So now try the next problem. Based on our last problem, how do you think you would approach x equals 2? I'm going to let you try it. In the equation x equals 2, that means that x will always be 2 and y could be anything. So this is really the equation 0 times y equals 1x plus 2. So we could switch this around and say if we were to write this equation out, x equals 2, we could think of it as 0 times y plus x equals 2. Or if you put it in where you saw for y in terms of x, it would actually be not as helpful, but 0y equals -x plus 2. So it's a lot easier though to think of it not solve for y for this particular case because we're looking at just x equals 2. So anyway, anything can be y and that 0 is going to multiply it out. So we can see that this works. I chose 4, 0, and -3. So if we look at, so with the ordered pair 2, 4, regardless of which of these equations I look at, the ordered pair is going to work. So if I'm looking at 0 times y, and y is 4, put 0 times 4, plus x is 2, equals 2, I end up with 0 plus 2 equals 2, which gives me a true statement. If I look at the equation 0 times y equals -x plus 2, and I put in 4 in the place of y, and I put in 2 in the place of x, I end up with 0 equaling 0, which is also a true statement. So you can see that 2, 4 will work, and so will 2, 0 and 2, -3. So what kind of line do you end up with when you have x equal to some constant? A vertical line, right? And that will hold true for any equation where x equals some number. So let's say we have x equals -5. Well, for x equals -5, we'd come out to -5, and your equation is just going to pass through -5 on the x-axis. So one of the ways you can think about it, because a lot of people think x equals a constant should be a horizontal line like the x-axis, but that's not true, because x equaling -5 actually passes through the x-axis at -5. It's actually perpendicular to the x-axis. Therefore, it's vertical. X equaling 2 passes through the x-axis at 2. Therefore, it's perpendicular to the x-axis. So you have y equaling some number is perpendicular to the y-axis, and x equaling some number is perpendicular to the x-axis. So try this example. You could pick whichever ordered pairs you wanted, whichever x values. Y should always be -4, so you have a horizontal line that crosses the y-axis at -4. Use the following 5 x values and come up with 5 ordered pairs. And then go down to the next page and graph those 5 ordered pairs and draw a line to see what kind of graph you end up. This is what your graph should look like before you connect the dots. Now you would not know this, but this is not actually a V. This is a very special type of function called a parabola. And when you connect the dots, it looks more like a U. Mine's not perfect, but this is your basic shape of a parabola. Actually, it's a little bit more like that. There you go. So that's your basic shape of a parabola. And here's how you spell that. You'll learn more about parabolas in algebra, but you should be able to graph anything, any equation I give you, regardless. So use these 5 x values, come up with 5 ordered pairs, and graph this equation. Here are your 5 ordered pairs: -2, -1, -1, -3, 0, -3, 1, -1, and 2, 3. And here's what your graph should look like. This is actually a parabola as well. And you'll learn later is because it has the x squared in the equation. So again, tables can be used to graph any type of equation, and then you can use those ordered pairs to graph them.